So there's a number of ways that we can break down who's included or what's included in an ecosystem. And there's a hierarchical structure that we can look at when we talk about ecosystem components. And that's who lives in this ecosystem. So what species are you? And how many of them are you? So a single member of a species is the starting point for who lives in the ecosystem. One lone wolf lives in an ecosystem. That one wolf is a member of a population of wolves, so a single pack of wolves. Now, in the Yellowstone Valley and Park, there may be 2 or 3 different populations of wolves. Together, all three packs of wolves is not a single population. Each pack is its own population because they interact with each other over time. Now, the population changes over time. So over the course of a year, some members will die, some members will be born. That population is transitory in that regard. That population is also transitory the same way the single member of that population is transitory, as it may occupy different space over the course of its existence. So if a population of wolves is being migrated back and forth through the Yellowstone Valley, or is pushed out of the valley into another area, that population then becomes the population of a new location and ceases to belong to the population from whence it once came. So there's, transitory dynamics there. Within a population, there is a community, and a community is how all of those organisms work together. The case here is this pack of wolves have surrounded a single bison. That bison is a member of a population of bison, and this single individual is a single organism within this pack. But together, the 2 packs are part of a community, and other members of that community include the elk in Yellowstone National Park that interact both directly and indirectly with the wolves and the bison, with the squirrels, with the red-tailed hawks, with the black-cat chickadees, with the earthworms, with the plethora of different grass species. Everything that's living on this plot of land is considered a community. Whether they interact directly with each other or indirectly with each other, they all have a place and a role that is supportive of the functioning of the system. And within that, there are a number of different systems that interact with each other that occupy a habitat. So the habitat of this wolf variety, this timber wolf, is mapped out on the map below. But together, this entire habitat does not make up the ecosystem. This is just the range of locations where this organism can be successful and occupy different ecosystems. So certainly, as this wolf can be transferred, as wolves have been, from central Rocky Mountains in Canada to Yellowstone and be successful there, that wolf is going to find that, hey, I have bison here and I didn't have bison in where I came from before. They were extirpated there. This wolf didn't know about bison prior to that. As this bison, or pardon me, as this wolf, if it was to move farther north, it would probably find that it encountered timber bison as opposed to plains bison. Or it's going to come into contact with caribou as opposed to elk species. So the ecosystem, individuals within a community might change, those populations might change, all within the same habitat. So also within those habitats are some terms that I had mentioned before. And that first term within structure and function is what does each one of the members of an ecosystem do? And basically all they do is store and transfer energy within their body structure. And that structure is completely designed for where it lives. And where it lives fits a niche. It's how is it going to acquire food? What's its modality of a food acquisition or nutrient acquisition, energy acquisition? So that niche is different. So for those finches that I talked about, some of those finches' niche are to eat nuts, and some of those finches' niches are to eat berries. The polar bear's niche is to consume, in this case, lunch looks like it's a seal, but its function also is to consume other members of this particular high Arctic ecosystem. That's its niche. A grizzly bear that is injected into this landscape is not going to be successful. It has no niche to fill. It doesn't have the body structure to be successful to hunt this seal. It doesn't have the body structure to successfully hunt on the Arctic ice pack and acquire other organisms that are favorable to the polar bear. So the niche between a grizzly bear and a polar bear are widely discrepant. The niches between grizzly bears and brown bears or black bears are going to be discrepant as well. All right, so how they are structured fits how they acquire energy. Competitive exclusion, which I had mentioned earlier on, basically says no two species that occupy a similar niche are going to be in competition for that same niche at the same time or in the same place. They are going to exclude each other competitively from being successful. So an example of this would be a grizzly bear and a cougar that occupy the same national park, Yellowstone National Park, or maybe Glacier National Park in Montana. They live in the same place. They live in the same place in the same time period, but they acquire their food resources at different times of the day. They may respect each other's co-location, so they're not going to encroach upon where another one is. And out of that competitive exclusion, the grizzly bear is not an exclusive carnivore, it's an omnivore. So it's going to take advantage of eating other food sources, where the cougar is really looking for small and medium-sized game. When it gets kind of skippy and stressed, it might look for larger game. The grizzly bear, on the other hand, gets a lot of protein nutrients out of grubs and insects. He turns over a lot of stones in a day to get those. He also is a huge bear eater. Berry eater. Tons and tons of berries are important for fat production for the bear. He's also going to eat a lot of bear grass and vegetation as part of his diet. So that's part of this competitive exclusion, is one may have a more varied diet than the other to compensate for that competition. So all of those things are in play to make sure that both organisms are successful on the landscape. From those niches, then, we can have three different types of relationships that develop. A symbiotic relationship where both organisms benefit. That could be like lampreys on pilotfish, where the lamprey is basically eating all the parasites off of its fish, and so it gets sort of a free ride. It sort of hangs out with the fish that it's feeding parasites off of, and the fish that it's hanging out with doesn't mind, because basically it's keeping him healthy. So that's a symbiotic relationship. A parasitic relationship is one where one organism benefits at the demise of another. COVID-19 is not a bad example there, um, where some people die because of COVID-19. What happens with that organism is it wants to reproduce and go through its life cycle rather quickly before the organism that it's benefiting from dies. So that reproductive rate and the transmission rate is faster than the demise of the organism that it's benefiting from. And I've given you generalists and specialists already.